So here we have EFAW's 2407R-2500KV motor. This motor's been pretty popular these days, and it's pretty hard to find. So when I saw it in stock at Pyroflip RC, I just went ahead and ordered one for testing, because I was pretty curious to see what this motor could do and how it would compare with other premium motors like DYS and Emax 2306, etc., etc. So it comes in this box, protected by some nice foam, and they give you 4 M3x6, it looks like, screws for mounting, and a nylock. So the motor is pretty fully loaded with all the latest features that motors are coming out with these days. The armature is made out of 7075 aluminum, which is one of the stronger aluminum alloys. The shaft is titanium alloy, and it's fully hollow, so it's hollow all the way through. Let's see what it weighs with the factory wires, which are about 95 to 100 millimeters. So that comes in at about 34.5 with the included wires. So pretty light motor for this size. They're using a hex screw for retaining the shaft, which is pretty good. A lot of people like this because it's easy to remove the shaft and disassemble the motor. But you do have to be careful, just make sure you have some low strength thread lock, so that once you remove it, reapply some thread lock, and don't over tighten the screw. Let the thread lock hold it in place so that it doesn't come out and get lost. So among the other things, it's got high temperature magnets, high temperature copper wire, and 0.15 millimeter laminations on the stator, and a lot of weight reduction. You can see they got rid of the base, so it's a pretty minimal base, and pretty thin armature here. So we'll see a comparison against the other motors just to show you how, what the differences are. Let's take a closer look, and we'll go ahead and remove that shaft retaining screw. Make sure you have you use a high quality hex key, because if you use the cheap ones, what happens is their tolerances are off. So when you have to undo something this small, you want to make sure that it fits just right, because otherwise it's gonna end up slipping, and it's gonna cam the hex screw. It's gonna round it, and then it's gonna just make it difficult to remove. So I use these ones. I like using these ones, Banhus. Pretty affordable, and so far I like them a lot. They fit pretty well. It makes it easy to remove hex screws. So it's easy to remove. There we go. It's pretty strong magnet. So let's look at it on the magnifying glass. Okay, so here's the stator. As you can see, pretty neat windings. These are supposed to be hand wound, and that's a single strand wire, and it's supposed to be a high temp wire, as well as the magnets are supposed to be high temperature. There's the hollow shaft, and as you can see, it's hollow all the way through. Pretty light build overall. Laminations are 0.15 millimeter thick, and pretty minimal bottom mounting plate on the motor. So that's how they, you can keep it light. And so let's look at the stator height. It pretty much 7 millimeter in height. So it's got the nominal height 7mm, and the bell, as you can see, pretty well made. And magnets are, looks like they do have a little bit of roundness to them, and pretty chunky. So pretty good sized magnets. And just the one thing, the one kind of confusion I have is that it was mentioned on one of the threads that that the bearing on the motor is supposed to be 4x9x4, so 4mm bore by 9mm diameter by 4mm width. But the motor I got is actually looks like the bearing is only 8mm. It is 4mm bore, and the width of the bearing looks like it actually looks like more like 3mm. I don't think it's 4. Compared to the to some NMB bearings that I have, that I bought just to have as spares for other motors. They do look they're definitely smaller. So you can see, as you can see the difference right there. That's the 4x9x4. So when you put it on top, you can see it's not gonna, it's not gonna fit in there. So now let's put this back together, and there you can see the air gap in the motor is it's not extremely tight, but not loose either. So now manufacturers are kind of balancing the air gap. They're not making it super tight, and they're not making it too loose either. So that's pretty good. They're trying to find a balance, because if it's way too tight, yeah, you get a lot more power, but sometimes you end up getting a lot of feedback, and that causes noise to the FC. You get a lot of you may end up getting yaw shakes, which are in some cases are hard to tune out. So just having the right size air gap makes for a smoother motor. And a lot of people that do mostly freestyle acro, they prefer that, because you get smoother transitions. So here's a side-by-side comparison with other popular premium motors, the Emax RS-2306 and the DYS Thor, which is a 2407 motor as well. Not a lot of difference as far as diameter on these motors. They almost look just about the same. And you'll see like the differences are very minor. I mean, relatively speaking, it's only like they're within 1 or 2 millimeters, I believe. So let's just quickly get some measurements here so you can just get an idea. The Emax RS is 28.3 or so millimeters in diameter. The EFAW is 29.5, and the DYS Thor is 29.7 or so. So not a lot of difference. In height, you actually see more difference in height. The EFAW is actually pretty thin. Let's see if we can line them up right here. I don't know if that's gonna look good on the camera, but I don't know if you can get a sense of the actual dimensions of the motor. It's gonna be kind of hard to see because it's hard to line them up right here. So here's more or less the comparison on the profile of the motor. So you can see the differences in height of each motor. The EFAW is pretty thin, And the DYS is probably next, together with the RS. They're just about the same height overall. These two. DYS might be a little bit, maybe slightly taller, a little bit. But yeah, you can really see where they really try to cut weight compared to the other motors. Here you can see the I don't know if you can more or less see the difference in thickness of the bell, and also the difference in magnets. The EFAW has pretty chunky magnets compared to the DYS. Almost about the same as the Emax, but you can't see the Emax because the Emax got this full bottom right there. But overall a pretty well made motor. So now let's put it on the thrust stand and let's see how it does. Alright, so let's look at the thrust results for the EFAW 2407-2500KV. The motor actually measures at 2430 kV, so slightly lower than spec. That's pretty common for most motors. They'll either be slightly higher or slightly lower, so 70 kV lower. It's pretty common, so no worries there. So as we can see, the motor performed quite well. It's a little bit low on thrust for the size of the motor, but I imagine this was done on purpose because I think they're marketing the motor for its smoothness. So I believe this motor is more targeted towards the freestyle crowd. So for freestyle, you want a motor that's torquey and that has smooth power delivery. So typically those motors are characterized by lower top output, so they won't have like they'll have a lower max thrust than the real
powerhouses like other motors that have high thrust. But that doesn't mean that the motor is not gonna perform well. It's probably gonna have more thrust at the lower RPM range, so you might get a better punch out of the low RPMs. So mid-range, kind of like that. One other motor that's similar in size would be the DYS Thor, the 2500 kV, and that one has higher max output. It doesn't mean that this motor is gonna be any less. It's actually a little bit more close to the new Brother Hobby R5 2306-2450. This one's a little bit more powerful, but it kind of reminds me of that by looking at the table. You can look at those thrust tables to compare. So with that said, we can see that the motor does perform quite well on the 5-inch props, the 5043x3. Almost 1500 kV. It's clearing 1400 pretty easily, so that's pretty good numbers. And one thing to note also is that the amps are pretty reasonable, very manageable. It seems like the motor is pretty efficient. We're not seeing any alarming amount of amps, so that's a good thing. Perfect for freestyle. As we move on to the more aggressive props, it's clearing 1500 pretty easily, and on the 6-inch props is definitely pretty powerful, you know, so that shows it's got pretty good torque, clearing 1800 quite well. And the amps are also quite manageable, even though, you know, you may think that 49 amps it's quite high, but it's not. You know, this is max amp on a static thrust, the motor being driven by a power supply, and it's a single motor, so it's able to get all those amps from a dedicated power supply. In addition, I'm starting with a 16-volt setting on the power supply, so that's much higher than what you're going to see in the air using a LiPo. As the props unload in the air when you're moving forward, the motor is going to struggle less to make thrust. The air is moving over the prop and it's not able to grab as much air. That's how that works. So on 6-inch props, the motor is clearing 1800 quite easily, so that's pretty good performance out of the 6-inch props. And the amps are quite manageable, even though they showing 49. Don't think that this is pretty high, because this is on static, and also it's from a power supply. You know, the power supply is delivering all the current that the motor is asking for. And also my setting for voltage is 16 volts, so that's a little bit higher than what you'll see on your flight battery. And also in the air, the props on load, once they're moving, they're not able to grab as much air because the air is moving past it at speed. So that causes the prop to grab less air, and it unloads basically. So the resultant is lower amps by about 25 to up to 35% is what I've seen. So that's why I say the amps look quite manageable. So I'm thinking the max burst on a 6-inch prop in the air is going to be about 30% lower. So that's how I figure these amps to be quite manageable. So overall, the motor is performing pretty well. Again, as I said, it seems that it's aimed at freestyling. Not that it can't be used for racing, but other motors may have a higher top speed as far as RPM and thrust, so they may have an advantage on full out racing. And also, as I mentioned earlier, as you saw on that clarification I made at the beginning of the video, I had this motor since June, and I stopped finishing the review because EFAW had mentioned that they were gonna send me their latest batch for testing. So I thought I might as well just wait. But the latest version sample never arrived, so I thought I'd just upload this one in the meantime. And I don't know if they're gonna send it, but I imagine it's gonna be somewhat similar to this, probably even better. Since I haven't seen any detailed reviews on this motor, I thought I'd just upload it. Anyway, I hope you find this review useful, and hopefully maybe they'll send me the latest batch so I can also review it and see if there's any differences. But anyway, a pretty good motor, I think. Looks pretty well made, and even though it had some issues that we've all seen on the forums, it seems that EFAW has taken care of those issues and customers pretty well, and they have revised the motor so that the issues appear to be gone, I believe. Haven't been following the status of if the motor is readily available now, but I know it's always in demand. It's a motor that it's kind of hard to get, I guess. Anyway, that's the end of the review, and thanks for watching. Until the next video.